Welcome to this session. This session, we are going to solve these two problems on applications of properties of determinants. Now let's solve the problem. First one is to show that this determinant is given by a squared into a plus x plus y plus z. So proof of one. So we have a plus x, 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 y, a plus y, y, z, z, a plus z. Now, let's say row 1 to be row 1 minus row 2, then row 2 to be row 2, row 3 to be row 3. So then this determinant will be this minus this will have a, and then minus a, 0, x, and then a plus y, z, x, y, a plus z. Remember, we are allowed to play within rows and within columns. So with this result, we can say, let's now go and play with columns. So column 1 to be column 2 to be the same as column 2 plus column 1, column 3 to be column 3, column 1 remain to be column 1. So this leads to determinant of A. So this plus this is 0, x. This plus this will give us a plus x plus y, z. This is x, and then x plus y. This is a plus z. That's what we have. Now, because we have 2 zeros on the first row, then let's use compact expansion to find the determinant. Sign here is plus, minus, plus. So this determinant will be equals to a times determinant of a plus x plus y which will be a into a plus z times a plus x plus y minus z into x plus y So that's what we have. And so this will be the same as a into, now you see here there's no common, so let's just open this. So we have a squared plus ax plus ay plus az plus xz plus yz minus xz minus yz. This will be a into now yz minus x. So we have a squared plus ax plus ay plus az. And we see everything here has an a, so factor it out. So we'll have a squared into a plus x plus y plus z. And this is what was to be proved. Now, second part, we are told that if omega is one of the imaginary cube roots of unity, find the value of the determinant 1 omega squared omega squared 1 omega squared 1 and then omega. So let's first say rho 1 to be rho 1 plus rho 2 to be rho 2 and rho 3 to be rho 3, just step by step. So we'll have 1 plus omega plus omega squared 1 plus omega squared. This will be omega squared 1 omega squared 1 omega. Then next we say let rho 1 be rho 1 plus rho 3, let rho 2 to be rho 2, let rho 3 be rho 3. So by doing that, this determinant will be transformed into determinant of 1 plus omega squared 1 plus omega squared 1 plus omega squared omega squared 1 omega squared 1 omega. So that's what we have. And then if omega we are told that omega is one of the imaginary cube roots of unity. So unity, cube root of unity means cube root of 1. So so remember, so when we say omega square 1 plus omega squared, then this will give us, so remember to find the cube root of omega, so I squared, cube root of 1. So the first thing we have tan, so you have a complex number a plus bi, then tracing to power third, so we'll have z1 is given by 1 Z. So 1a, so we have 1 plus 0i. So which means that this is the same value as 1. So saying raised power third is the same as raising this one to power third. So the angle is tan inverse of b over a. So 0 over 1 is tan inverse of 0. So this angle is pi over 2. So that cosine of theta plus I sine theta. So the angle which gives us tan to be 0 so tan to be 0, so tan inverse of 0 is 0. So remember, if you are to plot 1 on the Argand diagram, so this is imaginary axis, this is the real axis, then 1 would be somewhere here. So tan of 0 is the same as tan of 360 degrees or tan of 0 degrees. So tan of 360, yeah. So it is the same as cos of 2 pi plus I sine 2 pi raised power third. So that cosine of 360 degrees is 1, as should be. Then sine of 360 degrees is 0. So then now, remember to express any complex number cos theta plus I sine theta raised power n, or nth root of this one here, or raised power n is the same as cos of n theta plus I sine n theta, and saying cosine of theta plus I sine theta. Remember, all this I'm doing just to explain why this value will be giving us 0. So this, the analysis I'm doing here is to substantiate that 1 plus omega squared is 0. Theta power n is the same as cos of theta over n plus I sine theta over n. So we have cos of 2 pi plus I sine 2 pi raised power third. So the same as cos two pi times n over 3 plus I sine 2 pi n, or say k, over 3. And this k runs from 0, 1, 2. So when k is 0, so the first value will be given by cos 0 plus I sine 0, which is 1. When k is 1, so z1 would be, so 360 divided by 3 is 120. So cos of 120 plus I sine 120. And then cosine of 120 is negative a half. Sine of 120 is sine of 120 is root 3 over 2I, and then K equals to 2, Z2 would be cosine of, so 360 times 2 divide 3 is 240 plus I sine 240. So cosine of 240 is negative a half, and then sine of 240 is negative root 3 over 2. Negative root 3 over 2I. So we are told that omega is one of the imaginary roots, so it can either be this or this one here. So taking this to be that root, so omega squared would be negative a half plus root 3 over 2I plus negative 1 over 2 plus root 3 over 2I. This will give us 1 over 4. This will be minus root 3 over 4I. This will be plus minus root 3 over 2I. Then this will be minus because I times I is negative 1. So this will be a quarter minus 3 over 4 is negative a half. And then minus, so this 1 over 4 plus 1 over 2, this will be minus 3 over 4 root 3I. Now, if we add this one to omega, which is negative a half plus root 3 over 2I, and then we add 1, so we'll have negative a half plus negative a half is 0. And it's negative 1, then plus 1, 0. And then minus 3 over 4 and then plus so negative a half plus 3 over 2I squared plus, so we have 1 and then minus a half plus root 3 over 2I squared. So this is the same as 1 minus a half plus root 3 over 2I. So this is what I'm to have 1 plus omega squared. And then this will give us, if you have a plus b squared is a squared plus b squared minus 2ab. So my a is negative a half. So it'll be plus 1/4. And the squaring this one, I get I squared is -1, so I have negative. And then 3 squared is 3. And then square of 2 is 4. And then I have twice this by this, I have a negative sign. And then this time this is, so it'll be root 3/4 times 2. So I'll get root 3/2i. And you see clearly that this will give us this, and this cancels out. So remaining that 1 minus 1/2 plus 1/4, and then minus 3/4. And that gives us 0. So therefore, this determinant here, the determinant we have here, is simply 0, 0, 0, and then omega squared 1, omega squared 1, omega. Since, so you write this one, you say since 1 plus omega squared is 0, as we have shown down there. And therefore, all these determinants will be 0 since row 1 consists of all 0 elements. Then that will be the conclusion for that problem. Thank you.